Hello everyone, and welcome to another episode of Math with Dr. War. Today we're going to be solving quadratics by the method of factoring. Now, if you're going to solve a quadratic and use factoring, there are just 4 simple steps. Set your quadratic to 0. Your next step is to factor your quadratic. Once you've done that, set each of those factors to 0 and then solve your equation. Let's begin. So here I have x squared plus 15x equals to negative 56. Now I know that this is a quadratic and not a linear equation because notice my greatest exponent is a 2. So whenever you see your variable being raised to the second power, whether it's an x squared or a y squared or a z squared, then you know you have a quadratic and you can't use the method like how you would a linear equation. So I notice I have a quadratic and it's equal to negative 56. It does not equal to 0. So your first step, I must set it to 0. So to do that, I remove the negative 56, and to do that, I'm going to add 56 to both sides. Now I don't have any room on the left hand side, so I'm going to write the plus 56 under the 15, but please note they are not like terms. I cannot add 15x and the 56. However, what I'm going to write on the left hand side is going to be x squared plus 15x plus 56, and that is going to equal to 0. Remember that cancels, and equation must equal to a term, and our term is 0. Also remember, because we have to set it to 0, you're going to have to move something over to the left hand side. Always write your equation in decreasing order of exponents. So always have your x squared first, followed by your x, followed by your number. Your number, which is your constant, should be your last term. Now I have to factor x squared plus 15x plus 56. So from my videos, you've noticed that when I factor, I use this x. So here's my 56, here's my 15. Okay, I'm going to have x here and x. Everything is positive, so I'm going to have a plus and a plus. Now I'm looking for two numbers that when I multiply them, I get 56, and when I add them, I get 15. The only two numbers that will give me 15 would be 8 times 7. So when I multiply 8 times 7, I get 56, and when I add 8 and 7, I get 15. So my factors are x plus 8 and x plus 7, and please remember those are going to equal to 0. Next, I'm going to set each factor to 0, so I like to draw this line in the middle. So I have x plus 8 equals to 0 and x plus 7 equals to 0, and I'm going to solve this. So this is pretty simple. I'm going to subtract 8 from both sides. That cancels. I get x equals negative 8. Now you don't have to do this long solving. The best thing about this equation, which is now a linear equation because your exponent here is a 1, is that it's set to 0. So I always tell my students, okay, once you get here, I'm just going to focus on the plus 7. And I always tell them to choose the opposite. I'm going to write really tiny. I'm going to try to get it in. Choose the opposite. So this will be x equals, that is positive 7. Your answer will be negative 7. If you're not comfortable with choosing the opposite, please go here and just go through the motions of solving. Notice that if we went right here and take the sign with you, that was a positive 8. The opposite of that will be negative 8. So x equals negative 8. And you're finished. Your answer is x equals negative 8 or x equals negative 7. Let's try this again. So I have x squared plus 16 equals 10x. Again, we must set to 0. So I must get rid of this 10x. So basically, I'm going to subtract negative 10x from both sides. So I'm subtracting 10x. Over here, I'm going to write minus 10x. Remember, write your quadratic in order. So it will be x squared first, then minus the 10x, and plus 16 equals to 0. Notice I did not write x squared plus 16 minus 10x. If you did that, you're going to have a very hard time factoring. So always remember, your x squared, then your x, then your constant. So now we have to factor this. So again, you know I like my little x. So I have 16 here and negative 10. Now notice that my product is positive, but my sum is negative. The only way you can have a positive product and a negative sum is if you multiply two negatives. If you multiply two negatives, you get a positive. If you add two negatives, your answer is still negative. So here's my x and my x. So I'm looking for two numbers that when I multiply, I get 16, and when I add them, I get 10. That would be 8 and 2. And I always say check your factors and your sum. Well, not factors, sorry, your product and your sum. Negative 8 times negative 2 is positive 16. Negative 8 plus negative 2 is negative 10. So my factors are x minus 8 and x minus 2. And notice I'm setting them to 0. I like to draw this line in the middle. I have x minus 8 equals to 0. X minus 2 equals to 0. Again, if you like to go through the motions, I'm going to start over here. You would add 2 to both sides like this. This cancels. X equals to 2. If you're confident, go right here where you see I'm putting this little cloud or bubble. Choose the opposite. So I'm going to write x equals, now that was a negative 8, so my answer would be a positive 8. And there's your answer. X equals to 8 and x equals to 2. And we're finished. Okay, let's try another one. X squared equals to 11x minus 28. So remember our rule. We must set it to 0, which means I need to remove the 11x and the negative 28. Now in class, students wanted to move the x squared. Now if you move the x squared, you would have to subtract it, which means your x squared would then become negative. And no one likes to be working with any leading term that is a negative. So I know that it's really tempting because it's just one term, but I would suggest you move these two terms over here. So basically what I'm going to do is I'm going to minus 11x and I'm going to add 28. So notice I'm doing the opposites. So over here I'm going to have my negative 11x and positive 28. And it's not that hard to move them. This cancels, you get 0. I get x squared minus 11x plus 28. When I was in school and we did this, basically what we usually did was just move things to the other side. Now because I'm moving the 11x over to the left, you must change the sign. So it was a positive, so when it comes over, so here's your x squared. When it comes over, it will be the opposite, so it'll be negative 11x. There's my 11x. And then when I move take the sign with you, the negative 28 over the equal sign, it will become a positive 28 equals to 0. Think of it as moving to another country. You're going to have to conform to their rules and policies or rules and regulations. So you can't be your same self. You have to conform. Now we get x squared minus 11x plus 28 equals to 0. Again, we're going to factor this. So I like my x. So I have 28. I have negative 11. So again, notice that my 28 is positive, but my sum is negative, which means that both of my signs will be negative. The only way you can have a positive product is if you multiply two negatives or two positives. But because my sum is a negative, you're multiplying two negatives. Because when you add two negatives, your answer is negative. And then this is pretty simple. What two numbers multiply to give you 28, but when you add, you get 11? That would be 7 and 4. So you have x minus 7 and x minus 4 equals to 0. Please don't forget this. I find students always forget that you must write equals to 0. And then from here, you have x minus 7 equals 0, x minus 4 equals to 0, and then solving. So here I'm going to cut on some time, put my little bubble. I have x equals, now that's a negative 7. I'm going to choose the opposite, positive 7. Okay, here's my bubble again. I write my x equals, that's negative 4, so choose the opposite, positive 4. So your answer is x equals 7 or x equals to 4. Okay. I have two other examples here. Now I have x squared equals to negative 5x. And again, we're trying to solve 4x. So remember, we must set it to 0. So I'm going to add 5x to both sides. This will be x squared plus 5x equals to 0. Now here, notice I only have two terms, and notice both terms have variables. So you're going to perform a Gcf factoring. I find that when students get to the ones with two terms, they're kind of stuck on what type of factoring to use. So I always say, okay, you have two terms, both terms have variables, use GCF. Okay, what can we factor out? X. So I have x, and inside I have x plus 5 equals to 0. And then remember, we're going to set them to 0. So this is x equals to 0. So this is already solved. This is x plus 5 equals to 0. So solving for x, here's my little bubble around the plus 5. So x equals negative 5. So your answer, x equals to 0 or x equals negative 5. I have 18x squared equals to 30x. Again, they must be set to 0. So I'm going to minus 30x on both sides. I have 18x squared minus 30x equals to 0. Again, I only have two terms and they both have variables. So GCF factor. What number would divide 18 and 30 evenly? That would be 6. They both have x's. Take the smaller one, x and x. So my GCF is 6x. And when I divide, I'm going to get 3x minus 5. So remember, set each factor to 0. So I have 6x equals to 0 and 3x minus 5 equals to 0. Now here, you're solving for x. If you divide both sides by 6, guess what? X equals to 0. So I don't care if you have 6x equal to 0, your answer is x equals to 0. You could have 5x equals to 0. Your answer will be x equals to 0. And then over here, solving for x, add 5 to both sides. So you have 3x equals to 5. And then last step, divide by 3. So your answer is x equals to 5 over 3. And that's your answer. Can't make a nice perfect square, but there's your answer. If you want to get your answer quicker, I'm going to go up here. So you have 3x minus 5 equals to 0. You're going to write x equals, now start here. I always start with the number, so you notice that that's negative 5. So the opposite will be positive 5. And then this 3 right here is your denominator over 3. So this is your numerator. So choose the opposite, 5, and then that's just your denominator. Last two examples. I have 18x squared equals to 25. Remember, they must be set to 0. So I'm going to subtract 25 on both sides. I have 81x squared minus 25 equals to 0. Alright, so notice I have two terms again, but in this scenario, I only have one term which is a variable. So here, notice that 81 is perfect, x squared is perfect, 25 is perfect. They both have a subtraction sign. I'm losing my words. Subtraction sign. So to factor, you're going to use dots, which is the difference of two squares. So I always tell students, look, when you look at your equation and it only has one variable and all your terms are perfect, you're using difference of two squares. So basically, just open your parentheses, equals to 0. 81 is 9 times 9. X squared is x times x. You have a negative, plus, and minus. That's the only way you can get a negative. And 25 is 5 times 5. Because basically, what number multiplies itself twice to give you 25? And then from here, you have 9x plus 5 equals to 0. And 9x minus 5 equals to 0. And remember that trick I just, well, it's not a trick. But remember that process I just did? I'm going to write x equals. So notice this is positive 5. So that will be minus 5 over, and there's my denominator 9. And then I'm going to write x equals. Again, I look here. This is a negative 5. So it'll be the opposite, positive 5 over 9. And you're finished. Last one. You have 4 equals 9x squared. Remember that rule I told you? Always make sure that your x squared is positive. So I'm not going to move this. I'm going to move the 4. So I'm going to minus 4 on both sides because I like my x squares to be always positive. I can't deal with any negative x squares. So I have 0 equals to 9x squared minus 4. Some students don't like looking at it this way, so you can write it over. 9x squared minus 4 equals to 0. And then again, 2 terms, but you only have one variable. Perfect, perfect, subtraction, perfect, dots. So let's open our parentheses. Don't forget to equal 0. To get 9, 3 times 3. X squared, x times x. You have a negative plus minus. How do you get 4? 2 times 2. And what do you end up with? 3x plus 2 equals to 0. And 3x minus 2 equals to 0. And solving for x, remember, this is a positive 2. So you're going to have negative 2 over 3. Because remember, this is your denominator. And then over here, you don't even have to solve this because notice it's the same numbers, but the signs are different. So if that one was negative, this one is going to be positive. I hope this video has been helpful on how to solve your quadratics by factoring. And remember, please like and subscribe.